In this problem here, we have a quotient, and we're going to look at the critical values, and the critical values come from asking what values of x makes the numerator 0 and which values of x makes the denominator 0. Now this is already factored as much as we're going to factor it. So what are the critical values here? What value is going to make the numerator 0? -4. What value is going to make the denominator 0? 1. But of course, x cannot equal 1 because then this thing would not even be defined. But we're going to include that because it's going to be important in describing the behavior of this expression. So I'm going to draw my number line. I'm going to be careful about something here. Let's draw it right here. Okay, I'll label it x. And I'll put my critical values. So I've got 1 here at -4. And -4, that's going to give me 0 on the top. But what about this 1? I can't really put 1 in there because it came from the denominator. And if the denominator is 0, this whole thing is undefined. So I'm going to draw an open circle at that 1. And now I'll test my intervals. So let's pick some number in this leftmost interval, like maybe -5, all right? So if I pick -5, and I put that -5 into my factored form, put it here and just look at the sign. If I put it on the top, -5 plus 4 is negative, and then put it in the bottom, put that -5 in the bottom, -5 minus 1, well that's negative. And then I'm looking at this, a negative divided by a negative, well that's positive. So I'm saying now that if I pick any number in this interval here, put it in here, I'll get a negative over a negative, which is positive. So I'm looking at a positive, less than 0, false, no solutions there. Let's go on to this middle interval right here. Pick some number that's convenient. It doesn't really matter. They're easy to work with. What if I pick a 0 here? And then put that 0 back up in our factored form, which is the original. So if I put 0 on the top, 0 on the bottom, I'm going to get a positive here, a negative here. So I get a positive in the top, a negative in the bottom. Different signs, I'll get a negative. So we're saying that if you pick any number here, put it into this expression, you get a positive number over a negative number. Positive divided by negative is negative, and the statement is negative less than 0. Well, that's true. So there's our solution. So we got solutions in here. You know, I'm going to mark that so I can see it easily. So let's test our last interval right here. Pick a number in here like maybe 5. Now, if you put 5 back into the top, you get 9. That's positive. In the bottom, you get 4 is positive. So you're going to get a positive over a positive, which, of course, gives you a positive. So you're saying that if you pick any number here in this interval, bigger than 1, I don't know why I picked 5. I could have picked 2. Any number here is fine. But I picked 5. So that gave me a positive over positive, which is positive. But then I'm saying a positive number is less than 0. That's false. So no solutions there. So let's just make a claim. Where are the solutions? Well, if I just bring these numbers straight down like this, I'll have what? I'll have the -4, the 1, and then where are the x's? Well, the x's are right here, right? They're right in between. If I bring those x's down, the x's are right here. So I would write my x, and then the arrows go this way. The 4 is included, -4 is included, so less than or equal to. The 1 is not included, so strictly less than. And there's our solution.